In this video, I will demonstrate how a multiple tape Turing machine can recognize the same language as a single tape Turing machine. I will show you how much simpler it is to use multiple tapes rather than one tape, although it is possible to do both. So let's go ahead and look at the single tape Turing machine. First thing to think about is what is on the tape when we start. That is the string that we're going to be trying to simulate on this machine. The string I'm going to use, just for example, is AAA, and that's recognized by this language because we have 3 A's followed by 3 B's, and there's an equal number of A's as there are B's. To simulate this string using a single tape Turing machine, we have to mark off 1 A and 1 B at the same time until there's no more unmarked A's or B's. As you can see, when we read the first A, we mark it with a blank. Then the tape head will move right until it reaches the first B. This is when we start using X to mark off variables. So we mark this B with an X, and then we fast forward to the end of the string, and then we rewind all the way to the beginning of the string. Then we move right until we find the next unmarked A, and mark that with an X. Then after that, move right until we find the next B, and replace that with an X as well. If we look at the tape progress after the simulation is done running, we'll notice that the tape head, which is shown by the highlighted portion on each line, fast forwards to the end of the tape and rewinds to the beginning of the tape so many times. So let's keep that in mind, and now we'll look at a 2-tape turning machine that recognizes the same language. We can see that the transitions here look a little different than the transitions for the single tape turning machine. Here, because we have 2 tapes, we have to tell each of the tapes what to do during each transition. That's why we see 2 transition statements on each transition arrow. So when the program first starts, this is what the 2 tapes look like. Tape 1 has the input string on it, and tape 2 is empty. In the one with the single tape, remember how we marked the beginning of the tape with a blank? Well, in this case, we're using 2 tapes, and we're just going to mark the beginning of tape 2. So for tape 1, the tape head will stay where it is, while for tape 2, we will read a blank, write a blank, and move right. Now the beginning of tape 2 is marked with a blank. So with the single tape Turing machine, we started marking pairs of A's and B's using X's. With this 2-tape Turing machine, the only thing we will be marking is the beginning of tape 2. Now that that's done, we're going to copy all of the A's from tape 1 onto tape 2. So for every A we read from tape 1, we'll write an A on tape 2, and both tape heads will move right. After we're done copying the A's, we'll move tape 2's tape head to the left so that it's on the rightmost A. Now tape 1's tape head is at the first B on tape 1, and tape 2's tape head is at the last A on tape 2. Now we'll just move tape 1's tape head right as we read each B, and move tape 2's tape head left as we read each A. We'll know if there's an equal number of A's and B's if both tape heads reach a blank space at the same time. Here's the progression of the tapes after we simulate our string AAA, BBB on it. Clearly, there are fewer transitions needed when we use multiple tapes in comparison to using a single tape. Although it is possible to build both a single tape Turing machine and a multi-tape Turing machine that recognizes this language, when using the multi-tape Turing machine, we can see that the machine can decide if the input string is in the language much faster than the single tape Turing machine would. And we don't have to mark each variable when using multiple tapes, where we do have to mark each variable when we use the single tape Turing machine. I hope this video helped you to better understand the similarities and differences between single tape and multi-tape Turing machines. If you want to simulate some other strings on these machines to get more familiar with them, you can go to graphstate.com and simulate any string you want. Thanks for watching.